word that you had was rigid. And it said, turn to page 217, what is the definition as rigid as it pertains to shapes? So what I wanted you to write, or summarize, as long as the sides do not change or break loose, the shape of the triangle will not change. And that is what rigid means. So when you have something that's rigid, it means you can't bend it, you can't break it, it stays the same. Okay, it's not going to change shape or size. Okay, so on your so the side triangle would be considered rigid because when you make it, it's not changing shape when somebody else makes it. Okay, it's going to be the exact same triangle regardless. Okay, because it is rigid. Some of these other ones that we're going to learn, it's part of section 4.3. They're not rigid. Like when you go to make it, as long as you're not watching somebody else, your triangle is probably not going to be the same. Okay, so these ones are rigid. Okay, so rigid is that definition. Okay, then we jumped down, we did our activity number 2. So we're going down to number 3 and filling in our postulate that was part of the activity 1. Okay, so this one was at the bottom of your notes. Okay, so if the sides of one triangle are congruent to the sides of another triangle, then the two triangles are, what do you think? Congruent. Okay, but we'll just put this symbol. Unless you want to write out the words, you can write out the words. Okay, so we're flipping to our next page. So on number 4, what is your activity 2? Okay, which was the part 1 where we did the angle and added the two sides onto the side. Okay, so in that yellow box, you also had a postulate, which was for the side angle side. Okay, what are the two things they gave us that are the same in our postulate? Sides. Okay, so if two sides and their what? Angle, good. And one triangle are congruent to the two sides and their angle. So assuming that the numbers are the same and the angle measurements are the same, then those two triangles are congruent. So what they're saying is if you were to compare your side or your side angle side with somebody else's and they're the same measurement, the same angle measurement, the same sides, then they're going to be congruent. Okay? I mean, obviously, you're not going to compare your 246 to your 234. Those aren't going to be. Okay, they have to actually have the same measurement. Okay, then we went to our part 2 one, and this is one we already looked at where we moved those two up to the side. Okay, so we're filling in this one. Okay, so on this one, what do we have 2 of now? Angles. Okay, so if 2 angles and the side in one triangle are congruent to the 2, and then the same thing here, angles and their side in another triangle, then the 2 triangles are congruent. So angle, side, angle. So it means there's 2 angles, but a side is in between it. Okay, so sample problem. You're not writing anything, you're just looking up here. So this is what we're going to see in this section. So it says in each pair below, the triangles are congruent. So they tell you that they're congruent. Tell which triangle congruence postulate allows you to conclude that they are congruent based on the markings in the figure. So these are those abbreviations. So you're using A's and S's. Okay, A's for the angles, S for the sides. Okay, so we need to know that the tick marks are the same, because otherwise if the tick marks aren't the same, then obviously they're not the same triangle. Okay, so this one has a 1, 1, a 2, 2, and a 3, 3. So we know they're congruent, which they said that in the directions up above. Okay, so what is the postulate that makes these guys congruent? S, 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 side, 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 right? Because there is no angles given in this drawing, right? That makes sense? Okay, so that's part of what we're doing is just classifying them. Okay, so then this one, they say they're congruent because our tick marks are the same. So you got to pay attention to that. So sometimes they'll trick you and they'll maybe have the same tick mark, but it'll be over here. It'll be two angles and then a side over here, but it's not in the same spot. So you got to pay attention to that as well. Okay, because if this was like this and they had a tick mark here, that would not be the same because this would be an angle, angle, side, which is not the same as an angle, side, angle. Okay, so pay attention to that. Even though the markings are the same, they have to be in the same spot. Okay, so what would this one be called? Angle, side, angle. Because the side is in between the two angles. Making sense? Okay, next one. What do you think this one's called? Side, angle, side. So side, angle, side. The angle is in between the two sides. And it's fine if this is flipped, because it's the same thing with yours, just because you might have put your 2 on this side, somebody else can put their 2 on this side and still construct it. Okay, so just as long as everything's the same and this angle is in between a 1 and a 2, and this is in between a 1 and a 2, then it's congruent. Okay? You good? Okay, so now I got to jump to the 4.3 section. I think that was the end of the 4.2 section. Okay. So now the 4.3 one. Oh, I think this is kind of interesting because they actually use this quite a bit in investigating and stuff. In the method of triangulation, observations at 2 different places each take note of their line of sight of an object. The location of the object is the point where the lines of the sight cross. So they use these with cell phone towers. Okay, when you've got cell phone towers and then they can locate people. Okay, they're actually using this triangle, trying to figure out angles and distance away from things to locate people when like they talk about pinging your cell phone towers and knowing the location of that. They're actually using this triangle congruent stuff to figure out solving for sides and angles and stuff. Okay, so number 5 on your notes. Okay, you were told to write this. So if you didn't get this written down, make sure you have those 3. Okay, so AAA, so A stands for angles. That means that we have, you don't have to write the word combination, okay, but write AAA, which means there's 3 angles. AAS means that there's 2 angles and a side that is not between, okay, because notice that the side is not between the 2 angles. It's on the outside, okay. And this is the one that we don't say, but we can say backwards, okay. So we're not going to list it on our paper as ASS. Okay. We're going to write it backwards as SSA. Okay, because I know he'll be the first one to write it, and then he'll giggle. Just wrote that word. Okay, he'll do it all the time. Okay, so that's 2 sides and an angle that is not between them. Okay. Now, I want you to categorize these and write off to the side that these are the ones that are not always true. Okay. The ones that we did where it was a side, 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 and the angle, side, angle, those will always be the same if you compare somebody else's. Okay? Okay, we're going to try a little experiment. Do not look at somebody else's. Okay? I want you, next to where you wrote AAA, I want you to draw a triangle that looks to be like a 60, 60, 60. So it's an equilateral, equal angular triangle. Draw it next to where you've got space off to the right-hand side. Okay, so remember we said side, 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 when we did the side, side, side one with the straw, or not straws, I don't want to say straws, noodles. If you were to compare it with somebody else's, your triangles, if you put them over the top of them, would have been the same. Okay? So if you're comparing with somebody else that's next to you, do you think you're going to get the exact same shape? Is mine the same shape as yours? It is? So if you were to put your paper on top of my paper, would it be the same size? No. So this is angle, angle, angle. So all we know is that the angles are all 60, 60, 60. Okay? And I can make an equal angular triangle, and your equal angular triangle is not the same because we need to know the side lengths. Okay? So on this one right here, all my sides are the same, right? So if I said, you make a 4, 4, 4, then yours is going to be the same. But we didn't say anything here, we just said angles, okay? So if this is an angle, 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 and that's all we don't know anything about the sides, it could be the same. You just happen to make the same one, but it's not always going to be the same because my size of my angle, angle, angle is not the same as yours. Mine is bigger probably, okay? So that's why it's not always true, okay? It can be, it's just not always. So that's an example, okay? So on the angle, angle, side one, it depends on where you're going to put the side, okay? So we could have, if I can just, okay? I can have an angle, and a side, okay? Or I can have an angle, and a side. So they're in different locations, okay? So it doesn't make them to be the same. So it has to be exactly the same spot in order for it to be true. If it's not, then you've got to look at where the location is at. Okay.
You did a angle side.
I did. I made angle side. And the other one. Okay, so same thing with that one. So side, side, angle. It could go side, side, angle, or side, side, and then the other angle. Okay, so you got to look to see where the location of those are at. So those are not always true. Okay, then we jump to number 6, which was just you guys copying the postulate. Let me find it. Oh, so here's another example. So this one's angle, angle, side, okay? And this one is angle, angle, but then the side has moved over to the other side. So these are not congruent triangles. So that's another example of drawing those. Okay, so this was vocab that you wrote. So 2 angles in a non-included side of one triangle are congruent to the corresponding angles in non-included side of another triangle. Then the triangles can be congruent, okay? But again, you have to look at the drawing. Make sure it's in the same location, okay? Can't be in different locations. Okay, so it says, which pair of triangles below can be proven by to be congruent by angle, angle, side? Okay, so looking at these 2 right here. So it has to be in the right location. So on A, can we prove that by angle, angle, side? Yes. Okay, so we've got an angle, the tick marks are the same, and the side is on the outside, and it's in the same location. So we can prove that one. Okay, what about this one?
No.
No, not the same. It's still angle, angle, side, angle, angle, side, and angle, angle, side, but that you can't prove this one, okay, because they're in different locations. This one's across from the 2, this one's across from the 1. Okay, so this is what they're taught. It's not 100% all the time. Okay, what about this one? Can we prove this one?
Yeah.
Yes, it's just flipped, right? Okay, so you have angle, angle, side, and then angle, angle, side. It's across from the 1, it's across from the 1. It's just been flipped. It is congruent. Okay, what about D?
No.
No. Okay, it's angle, angle, side still, but this is across from the 2, and this one's across from the 1, so it'd be a no. Okay. So really all the ones from 4-3, you really need to pay attention, okay? So you're going to be classifying and saying whether or not they are congruent to each other. I believe, HL, which was your number 7. I didn't have you draw something, and I do want you to draw on your construction. On number 7, it said blue box on page 229, the HL theorem. Okay, hypotenuse is the long side of what type of triangle? A right triangle. So if the hypotenuse and the leg of a right triangle has to be a right triangle, okay, are congruent to the hypotenuse and the leg of another right triangle, then the 2 triangles are congruent. Okay, so you're going to draw this one, okay, because this is an example of HL, not this one down here. Okay, I'm just explaining this. So they will either have them drawn or they'll have them written out, like saying it's a 90-degree angle. Okay, and then you have to like sketch the ABC, what it would look like. Okay, HL means the hypotenuse and a leg is marked, and it's a right triangle. Okay, so here we have a right triangle because it's either going to have a box or it's going to say it's a 90. Hypotenuse is always the long side, so that means that that's marked. And then the leg has to be marked. So, and it doesn't matter if it's this leg or this leg. Okay, it just needs to be one of the legs. Okay, this is not HL. Okay. It's a right triangle, okay, and the legs are marked, but what's not marked? hypotenuse. Okay, so don't get those confused. Just because it's a right triangle doesn't mean all right triangles have to be HL. Okay, they can be called side angle side. You good? That makes sense? Okay, so I just want to make sure that you had an example of that one. Okay, so I'm going to get you started